Let's look at how to solve these common Newton's second law problems. First, I want us to go through the procedure. Step 1. Choose a reference XY planes individually for all objects. This is necessary for the sake of finding force components. Step 2. Make the direction of acceleration positive for all individual objects. So objects might be going at different directions. Make sure the direction that the acceleration is going at is actually the positive direction. This means all the forces pointing in that direction of acceleration are actually positive. All the forces that are going against that direction will be taken as negative. Step 3. Draw a free body diagram representing all forces and their directions acting on those objects. Do not show components yet because we'll do components on step 4 when you have to resolve all angled forces that are initially not on the x and y plane, and then we want the effects of those forces in the y and x plane. This is what we mean by x and y components. Step 5. Write the Newton's second law equation for both objects. This is F net equals to ma. Step 6. You have to calculate important forces in the stationary axis, in other words the y-axis. This is normally the normal force for finding frictional force. So we know in the y-axis there's no movement when an object is on a plane, when an object is on a surface. So the acceleration in the y-axis is equals to 0. So we're going to use the sum of the forces in the y-axis equals to 0. Remember in grade 11 you did vectors in equilibrium. So this is exactly the case. When there's no movement in the y-axis, all the forces, when we take them and we sum them, they are going to give us 0. Step 7. Substitute all the forces in the axis of acceleration. This is usually the x-axis, and then solve. You may need to solve for tension and acceleration simultaneously, whereby you have to find acceleration first, then you can back substitute to find the tension. Okay, let's look at the first example. The question says, Tom pulls a 10 kg block attached to a 5 kg block by a light inextensible string of negligible mass with a force of 50 Newton at an angle of 30 degrees with the horizontal as shown below. The 5 kg block experiences a kinetic frictional force of 10 Newton. The coefficient of kinetic friction between the surface and the 10 kg block is 0.35. The question says, calculate the tension in the rope and the acceleration of the system for 14 marks. Make sure you note down all the given data. Make sure you translate all the given data in your diagram and on your free body diagram. Okay, so the first thing we want to do, I want to show you how this is going to look like. So we are pulling at 50 Newton on box 10 kg, which is attached by a rope that is not allowed to extend to a 5 kg block. So these two objects are going to have the same acceleration. Now let's choose our reference Cartesian plane, which is going to look like this. X is positive in the direction of acceleration, y is positive upwards. Then let's draw the free body diagram. For the 5 kg block, first we put a dot that is going to represent our body or our box. A force that is always there on a free body diagram is Fg. Because we have a surface, we have the normal force. We have a rope that is pulling the 5 kg block in the direction of acceleration. So there goes our tension. And we are told that there is friction. So Fk. For the 10 kg block, we put a dot to represent the body. We have Fg, which is always there, and it's applied vertically downwards. Due to having a surface, we have the normal force, and we have an applied force of 50 Newton at an angle of 30 degrees. And we have a tension force which is going opposite direction of motion due to it being attached to another block. And then we'll have the frictional force because we are given the coefficient of kinetic friction. Now let's look at the force F. It is at an angle, but we want to work with forces that are exactly on the X and Y reference planes. So we need to find the components for that. Let's represent the components on this diagram here. We have Fy, which can be translated to the other side. We have Fx, which is exactly the same if we put it on the top. Remember, these are right angle triangles. Now, to figure out which trig ratio I use to find which component, I'm going to draw an arrow for myself to represent which side is the opposite side, which is our Fy. So I'm going to say Fy equals to the magnitude of F multiplied by the sine of the angle 30 degrees. Then I get 25 Newton. The other side automatically is going to use the cosine of 30 degrees, and then I get 43.30 newtons. So here's my free body diagram with components. Then I'm going to write the Newton's second law equation for both the objects. I'm going to look at the forces that are in the direction of acceleration that are causing motion. And then I'm going to take tension as positive because it is going in the direction of acceleration for the 5 kg block. And then I'm going to minus Fk, which is going opposite the direction of acceleration. This is all equal to ma. We do the same for the 10 kg block. Fx, which is the component of F in the x direction, is actually in the direction of acceleration, so it's positive, and the rest, which is T and Fk, are negative because they are going in the opposite side of the acceleration. This is all equal to ma. Notice we are solving all these two blocks at the same time. This is very useful. Let's substitute what is known for the 5 kg block. Tension is unknown, but Fk is given to be 10 newtons, which is equals to 5 for the mass of the block multiplied by the acceleration. Let's do the same over on the 10 kg block. But we have to find the frictional force because it is not known. So for the frictional force of the 10 kg block, we need to solve for the normal force because our equation for frictional force uses the normal force. Notice that the normal force is on the y-axis. So to find the force that is on the y-axis, we look at the formula for the y-axis, which is the sum of the forces in the y-axis are equal to 0 because there is no movement or there is no acceleration in the y-axis. So this gives us normal is positive because we chose up as positive, plus Fy, which is also going up, minus Fg for the 10 kg block, all equal to 0. Remember, you have to do this. This is where a lot of students actually lose marks because they claim that the normal force is equals to Fg. But this is not always the case. You have to find the sum of the forces in the y direction, equate that to 0, and then solve for any force that is going in the y direction. Then you get your normal force. So let's substitute. We know that our Fy is 25 minus Fg is mg, so 10 multiplied by 9.8 equals to 0. We get a normal force of 73 newtons. Now we can use the formula for Fk, which says Fk equals to mu k multiplied by the normal force. So we know our mu k was given to be 0.35 multiplied by our normal force, which we just calculated to be 73 newtons. If we do that in our calculators, we get 25.55 newton for the kinetic frictional force acting on the 10 kg block. So we can go and substitute that together with our Fx, then we get 43.30 for our Fx minus tension is not given, minus 25.55 that we just calculated for kinetic friction equals to our mass is 10 multiplied by acceleration, which is not known. Continue to work now. At the same time, this time we look at the 5 kg block. We have T equals to 5A plus 10. We just isolated the T there so that we can make that an equation 1. We do the same for the 10 kg block. If we make T the subject of the equation, what we get is T equals to 10A minus 17,75. Then we can make that equation 2. Since both the equations are equal to T, which is related for both these objects, so equating equation 1 to 2, we get 5A plus 10 from equation 1 equals to 10A minus 17,75 for equation 2. Now we can take all the terms with acceleration to one side and all the numbers to the other side. We get 5A equals to 27,75. Then if we divide by 5 both sides, we can get our final answer for acceleration to be 5,55 meters per second squared. Now for the tension force, you can either use equation 1 or equation 2 to substitute the value for acceleration. Then you'll get your tension, and both of the equations should give you the same answer. Always check both of them to make sure that your calculations are correct. In this case, I'll choose to substitute A into equation 1. Equation 1 says T equals to 5A plus 10. I'll substitute A. Then I get T equals to 5 into 5,55 for acceleration plus 10, which means my tension force is equals to 37,75 newtons. And we are done with that question. If you have further questions, address them in the comment section below. Let's look at the second problem. A 5 kg block is resting on a rough table as shown in the diagram below. The 5 kg block is connected to a suspended 2 kg block by a light inextensible string over a frictionless pulley. The coefficient of kinetic friction between the table and the 5 kg block is 0,5. A 60 Newton force is applied at an angle of 10 degrees to the horizontal, which causes the 5 kg block to accelerate to the left. The question says, calculate the acceleration of the system. Let's look at what happens and then assign the direction of acceleration. They tell us that the 5 kg block will go to the left, which means the 2 kg block will go up. Normally, they won't tell you what the direction of acceleration is, and you have to pick it yourself. So let's look at what happens. We'll choose the left as our positive x direction and upwards as our positive y direction. Why? Because acceleration is going to the left for the 5 kg block and acceleration is going upward for the 2 kg block. Then now for the free body diagrams, I'll put a dot to represent the 5 kg body. I have Fg, which is always there on any object. I have the normal force because my block is moving on a surface. I have the applied force at an angle. I have the tension force. I have the kinetic friction. Then remember, we can always resolve any force that is angled to its components. So I'll do it now for F. So we have Fy as the vertical component and Fx as the horizontal component. Let's do the free body diagram for the 2 kg block. I'll put a dot to represent the body of the 2 kg block. We have Fg, which is always there on an object. Remember, in this case, it's not resting on any surface, so there's no normal force. But there is tension, which is pulling it up. So now we write the Newton's second law for both of them. And we're going to look at the forces in the direction of acceleration to substitute for F net. Fx is going in the direction of acceleration. Tension and kinetic friction are going in the opposite direction of acceleration. So that is why we have them as negatives, all equals to ma. We do the same for the 2 kg block. Acceleration is going upwards, so tension is positive and Fg is negative. All of that equals to ma. Then we substitute, our Fx is equals to F cos 10 degrees. If you don't know how, look at the first example. Minus T minus mu K multiplied by the normal force for the formula of Fk. Let's look at the 10 kg block. Tension minus mg, because Fg equals to mg equals to ma. Then we can solve for the normal force for the 5 kg block, which is resting on a surface. The sum of the forces in the y direction is equals to 0. This is what you always do. Then we can see the forces that are going upwards are normal and Fy. That are going downwards is only Fg. If we substitute there, we get normal plus 60 sine 10 degrees for Fy minus 10 into 9.8 for Mg. Then we can see our normal force is 38,58 newtons, which we can go and substitute back into our equation. F is 60 newtons cos 10 degrees minus tension, which is not known, minus our mu k is 0,5. Our normal force is 38,58. Our mass is 5 multiplied by acceleration. Over on the 2 kg block, we can see our mass is 2 kg. Our gravitational acceleration is 9,8. Then we substitute like that. Now, on the 5 kg block, we can represent the equation and simplify it into that form, which we can call now equation 1. We do the same for the 2 kg block, and we call that equation 2. When we equate both the equations, we get this expression. Then we can use that to find the acceleration, since acceleration is the only unknown there. So our acceleration is equals to 2,89 meters per second squared, which is our final answer for this problem. Remember, if they want you to find the tension, you can use either equation 1 or equation 2 to substitute the value of acceleration, then they'll give you the same tension value. Also notice for this problem, if we didn't have the applied force there, then we release the two objects. The 2 kg block will accelerate downwards while the 5 kg block will accelerate to the right. Then if that's the case, you can be able to solve that equation using the same method as we used here. We'll look at an example that is similar to that in the next problem. Remember, if you have questions, address them in the comment section. Here is the third problem. Two blocks of mass 8 kg and 4 kg respectively are joined with an inelastic string of negligible mass. The string runs over a frictionless pulley. The 8 kg block is on a horizontal surface while the 4 kg block is on an inclined plane of 40 degrees with the horizontal. The coefficient of kinetic friction for both blocks is 0,2. The 4 kg block accelerates down the slope. The question says calculate the magnitude of the acceleration of the system and the tension in the rope for 14 marks. So here's the diagram we are given. We know the 4 kg block is going to want to accelerate down the slope, as the question also tells us. So if we imagine the motion of these two blocks as we release them, we can see they go like that, and then we can assign the direction of acceleration and also the individual Cartesian directions. So for the 8 kg block, we'll choose upwards as positive, and to the right, which is the direction of acceleration, as positive. For the 4 kg block, it's very important that we rotate our Cartesian plane like this, because most of our forces are on an incline of 40 degrees. So there are your directions. Let's draw the free body diagrams. For the 8 kg block, here's your Fg. We have a normal force because it's on a surface perpendicular to that surface. We have the tension force that is going in the direction of motion. We have the frictional force in the opposite direction of motion. So all of our forces are along the x and y planes. For the 4 kg block, we have Fg, which is going straight down. We have our normal force, which is perpendicular to the surface. We have the tension, which is going opposite the direction of motion. We have our frictional force, which is always opposing direction of motion. And our free body diagram is complete. We can show the angle that Fg is acting at, and we always show it between the y-axis and Fg. This is going to help us find the components. When I'm finding the components, I'm going to eliminate the Fg force to show that now I have the effect of that force in the x and y directions. So I'm going to leave it as dotted lines to show that now I have its components. Let's write the Newton-second law equations for both of them. For the 8 kg block, here are the forces in the direction of acceleration. For the 4 kg block, here are your forces in the direction of acceleration. Fg parallel, which is the x component of the gravitational force, is the only force that is going in the direction of acceleration, positive, minus tension and Fk, which are going in the opposite direction of acceleration. This is equal to ma. Then we can express our Fk as mu k times normal for the 8 kg block. And we can express Fg parallel as Fg sine 40 degrees as our component there, minus T minus mu k times the normal force of the 4 kg block equals to ma. Now, as we can see, we are missing the normal force, which is easier to calculate. So we're going to solve for the normal force for both the blocks. Remember, always the equation is sum of the forces in the y direction are equal to 0 due to the acceleration in the y direction being 0. For the 8 kg block, n is going upwards, Fg is going downwards, so we have n minus Fg equals to 0. Then we can see that our Fg is just mg. We can substitute our m and g. Then the normal force for the 8 kg block is 78.4 newtons. Let's do the same for the 4 kg block. In the y direction, we can see the normal is going in the positive side and Fg perpendicular is going in the negative side. Those are the only two forces in the y-axis, so we equate that to 0. We know our Fg perpendicular is Fg, which is mg, the cosine of 40 degrees. Then when we substitute and solve for the normal force, we get 30.03 newtons. Then we can go back and substitute back into our respective equations. For the 8 kg block, T minus the coefficient of kinetic friction, which was given to be 0.2, into our normal force of 78.4 equals to the mass, which is 8, multiplied by the acceleration. Then likewise, in the 4 kg block, here is our substitution. We can simplify those equations, and for the 8 kg block, we'll call that equation 1. We simplify the 4 kg expression, and we call that equation 2. Then likewise, we're going to equate both the equations, and we get 8 multiplied by a plus 15.68 from equation 1 equals to 19.19 minus 4a from equation 2. Then we can see our only unknown there is acceleration, which means we can find the value. Then in this case, it works out to be 0.29 meters per second squared. The question wants us to find the tension in the rope. So we're going to substitute that value into either of the two equations. I'll choose equation 1 in this example. Then I'll have 8 multiplied by the value of acceleration, which is 0.29 plus 15.68. Then I get a tension force of 18 newtons. And this is all you need to know to master Newton's second law problems. If you have further questions, make sure to address them in the comment section. And I'll see you guys in the next video. Be sure to join my live classes and tutorials. You can also request face-to-face tutorials. All you have to do is to WhatsApp me on that number. Okay, don't forget to subscribe, guys. Like the video, support the channel. More awesome videos are coming. Cheers, guys.